friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore the concept of GitHub Action, and especially our focus will be whenever some event occurred in GitHub, how to integrate that with different AWS services. For example, when someone pushed the code in GitHub, if I want to move that code to AWS S3, or maybe I want to update my AWS Glue job based on the GitHub update of the code repository, or maybe want to update my Spark submit whatever is running in EMR cluster. All these things we are going to explore in this video using GitHub Action. So it is nothing but helping us in continuous integration, continuous deployment process, right from GitHub to our destination system. How to move the code, on that we are going to explore. Okay, so on a very simple architecture wise, if I want to explain what is GitHub Action, it can be shown like this way. Okay, that is, any people with repository access can push their code to a branch, open a pull request, opens an issue, create a release, or n number of events might occur with a GitHub repo, right? So whenever any people do any kind of activity like this in the GitHub repository, if I want to run an automation process, that is nothing but called as GitHub Action. Okay, so here you can see that whenever this kind of event occurs in GitHub repo, I can run some workflow. From the concept of Airflow and Spark, I hope you already know what is workflow. It is nothing but an automation process composed of series of jobs. Within jobs, we are having multiple steps which execute some particular operation, right? So let's just try to explore this automation process a little bit detail. So here the workflow can be shown like this way. So you can consider workflow is nothing but an automation process which is having multiple jobs. For example, in this workflow 1, we are having job 1, job 2, job 3. Within each job, we are having multiple steps. So just try to correlate with our Airflow, right? So in Airflow, we are having a job. Within job, we are having several tasks. Similarly, here within job, we are having multiple steps. So job we can call nothing but a series of tasks, right? And in individual step, we put some operation to be executed. Maybe copy the GitHub code to S3, or maybe update our Lambda code, or maybe update our Glue code, etc., etc. So I hope in a very high level you understood the concept of workflow, job, step, and what is GitHub Action. Now, without any further delay, let us directly jump into the practical session to understand all these concepts in much better way, right? So I will start from scratch. So as a first step, what I will do, I'll basically create a repository. Okay, so here currently I am in my GitHub repo and I will click on new repository. Okay, so repo name I can give demo GitHub Action YT test. Okay, description I am not putting anything public, that is fine, and I will create this repository. So here this particular repository is created. If I click on that, currently here nothing is there. If you want, you can go through all these documentations and points, whatever GitHub is highlighting. I'm not going to all these details, but rather I will directly upload some file in our this repo to start our GitHub Action process. Okay, so here you can see get started by creating a new file or uploading an existing file. I'll click on uploading an existing file. I will choose my file from desktop, and here maybe captured to this particular image I will choose, and here I will commit the changes. Okay, so here you can see in our this particular repo, this particular image is updated now. Now suppose whenever this kind of git push or commit happens, that time I want to make sure one thing, the code whatever is updated, that I want to move to AWS S3. There GitHub Action basically helps us. Okay, how it can be done, let us try to explore. So this is our GitHub Action code. I'll just go through individual process. So as a step 1, we have created the repo. We have uploaded some file, and now let's try to understand a very simple hello world GitHub Action code. Okay, no need to think this rocket science, just try to understand what I am saying, and if you have any doubt at any particular point of time, just mention in the comment section the timestamp where you got some doubt, and what is your doubt, that also you mention. I will try to reply back ASAP. Okay, so this is basically general structure of GitHub Action code. So first we need to provide the name of the workflow. So whenever we discuss about GitHub Action, the topmost level is workflow, which is basically encapsulating the whole automation process. Within that, we are having jobs. So as a first step, we need to provide the name of the workflow. And then we need to provide this information that based on what event that particular automation should run. So here I can provide on push event. That means when someone will push the code in that GitHub repository, that time this particular automation process should run. Okay. And then within workflow, as I told you, we are having multiple jobs. Within jobs, we are having multiple steps, right? So here you can mention jobs colon, and then here you need to provide job name or ID. And then here you need to mention it will run on what machine. So whatever automation process we are configuring here, it needs a server, and that server will be managed by GitHub only. We no need to worry on that. But we need to mention on what kind of server it will run. And GitHub is providing multiple servers. You can check the documentation to explore more. Here I am going to use Ubuntu system. Okay, I will discuss when I will show you the actual code. And within jobs, as I told you, we are having multiple steps. So here as a first point, we need to provide the name of the step, and then here I can provide what bash command or shell script it need to run. Using this run colon, we can mention any shell script. Okay, so as a very simple hello world program can be shown like this way. From this particular general pattern, I hope you can easily understand what this code is doing. First here name of the workflow is, I can give my first GitHub action. Okay, right? On push event, that is whenever some push event will occur in my GitHub repo, that time this particular job should be executed where the name is run shell commands. Okay, what it is doing, it is going to run on Ubuntu latest. Okay, so this is basically nothing but machine where the job will run. If you want to know little bit more about this Ubuntu latest, you can obviously check the documentation link. Let me just show you that. So here if you go to this, here runner images, here you can see Ubuntu latest is basically nothing but this one. Here you can see language and runtime, whatever packages are installed, whatever softwares are there as part of this particular Ubuntu machine, that also it has listed. So for example, if we want to interact with AWS from shell script, we need AWS CLI. Is it there? Yes, AWS CLI is there. Sometimes we need Python. Is Python there? Yes, Python is also there. PyPy is also there to install different Python modules from PyPy packages using pip command. So here you can basically get the idea what are the tools available, and based on that you can configure your shell script. Okay. So runs on Ubuntu latest, that also I hope it is understandable. Then within jobs we are having step. Currently here in this particular hello world program, only one job is available, and within one job only one step is available within this particular workflow. Okay, I kept it very simple because this is our first GitHub action. And as a step, what we are doing, whenever push event will occur, we are just printing echo hello. Echo hello will nothing but print hello in the console. As simple as that. Okay. So here what I will do, I'll copy this particular code, and then here I'll go to my repository just now whatever I have created, and then here you can see the action. I'll just go to action, and then here you can see get started with GitHub action. Here some deployment process it has already given as predefined template. You can use that, but here I am going to set up my workflow myself. Okay. So here you see where the workflow code is going to be written. It is within our repo, within .github folder. Within that there is a workflows folder, and there main.yaml. This is our YAML file, whatever will run as part of the GitHub action. Okay. All I'll do, I'll paste this code in this particular main.yaml, and then here I will commit the changes. As soon as I will commit the changes, what will happen? See, here in this GitHub action, I have configured that whenever some push will happen, that time this particular workflow or GitHub action should run. Now, whenever I will commit the changes, that means it is nothing but a git push or git commit we are doing. So as a result, what will happen? This action will be automatically triggered. So we'll see whether the action is running or not. So for that, what I will do, I will open this repo in a new tab. I will go to action. Currently here we are having no action. I'll just commit these changes. And commit message, let it be this one only, and I will commit this. Okay, it is committed, and here if I refresh this, here you will see that our GitHub action should start soon. Here I can go and then go to action. See here, it is running. It has already completed, so here it is giving a tick mark. Create main.yaml. So here this is our commit message, and if you click on that, it has basically shown the job what it has executed, run shell command, right? Here in the job name we have provided run shell commands. If you want, you can go inside that, and here you can see it has set up the job, and here echo a string. It is nothing but our step name. Here if you see the step name, I have provided echo a string, and then here it has ran that particular shell script, and echo is nothing but what it is doing. It is just printing hello in the console. That's it. Okay, and the job is completed. So I hope you understood on a very high level. GitHub action is nothing but whenever some event will occur in our GitHub system or GitHub repo, that time if I want to execute certain segment of code, that time I can opt for GitHub action. Okay, and using that particular code, we can deploy our GitHub code to some destination system, and all this operation we can do. Right, as simple as that. Now let's go to our next example, where what we are going to do, many times we put our Python code or PySpark code etc. in S3. From there EMR consume that particular S3 PySpark code and we make a Spark submit in the EMR cluster. This kind of operation we many times do. Then next example can be AWS Glue job. So in AWS Glue job, whenever we write some script, that script is basically stored in backend in some S3 location. So we should have a clear idea how to move the code from GitHub to S3. So if we are able to do that, then our deployment process with respect to AWS Glue, AWS EMR will be very easy. So the next thing what we are going to learn is how to move the code from GitHub to a particular AWS S3 location. Okay. So for that what we need, here we understood how to run a shell script. We can basically simply use AWS S3 cp command to move the code from GitHub local repo to S3 and all, that we understood, but at least we need AWS CLI and it should be configured one. So here in this particular Ubuntu machine, when it is running, we have already seen that AWS CLI is installed. Okay, so that particular headache is gone from our head, that we need to install AWS CLI where the GitHub action is running in the server. That is not required. So let's try to understand what job command I have written here. So here name of the workflow. So here workflow name I can give second GitHub action. Okay, on push event the job name is AWS CP. So here what it is doing, it is going to run on Ubuntu latest, the step name. As a first step, what we need to do in that particular Ubuntu machine where this particular GitHub action code will run, there the AWS configuration should happen properly before executing any AWS related CLI command. Otherwise, the Ubuntu server where this code is running, that will not able to interact with AWS due to authentication issue. So for that, we need to configure AWS credentials, right? So for that, there is a predefined step available. So that code is nothing but AWS-action/configure AWS credential @v1. Just you need to use that. And here in the with part, here you can mention your access key, secret key and AWS region in which your AWS service is available where you want to change using GitHub action. As simple as that. Okay. So just understand like this way, this particular step is nothing but a developer has developed. We are just reusing that. That's it. If you are trying to use that, just change the AWS access key, secret key, and if your AWS service is sitting in some other region, just change the region. That's it. Okay. Now here, as I told you, within a particular job, that is AWS S3CP, here we are having multiple steps. So first step is AWS credentials configuration, and the next step is we need to move the code from GitHub repo to S3. Okay. So for that we need an S3 location. So here I will go to AWS management console and I will go to S3 and I will create a bucket just for fresh demo. Okay. So here I will go to create bucket and the region I am keeping US East 1 only, and here GitHub Action YT demo test. Some name I have given, keeping all other properties default. I'll create this one. Okay. So if I want to move some code from this Ubuntu server to that particular S3 bucket, what we'll do? We'll simply execute AWS S3CP command. Okay. So here the destination is basically our this particular bucket, and let's see in GitHub, are we having any files which we can move in this repo? So we are having capture2.png, right? So let's try to move that. So here this is our command which is basically going to copy this particular capture2.png to our S3 bucket. Okay. Why I have given /, basically it is saying that in the main directory or working directory, capture2.png will be available. Why I am saying this? Because if you see this particular GitHub repo structure, in the parent level only capture2.png is available. So basically I am assuming that in the Ubuntu server where this code will run, in their working directory, in the same manner the folders or files will be arranged. Okay, right? So that's why in the root directory only capture2.png should be available, because here in the repo it is organized that way. So that's why I am expecting that and I am giving this kind of comment, right? So I hope you understood this particular GitHub action too. I'll just copy this and then here I will update my GitHub workflow code. Okay, main.yaml. So I'll just click on edit and here I'll paste it. Okay. So if you are doing some mistake in indentation, it will throw the indentation error. For example, if I'm doing like this, here you can see this highlighting in this red underline character and it is clearly showing that bad indentation of a mapping entry. Okay, because the name and run should be in same level, and as soon as you are keeping in same level, then the error is good. Okay, so let's commit the change and let's see whether the GitHub actions will be triggered or not. So here this is my action page. Currently here only one file is available, and let's see our S3 location also. So here I'll go to my S3. Here if I open that one, here you can see currently nothing is there. So what I can do, I can commit the changes. So again, this is another activity in GitHub we are doing. So we can expect that a workflow should be starting soon. So here you can see that the workflow is already triggered. The job name is AWS CP. Let's go inside that, and here it failed. Upload to S3. Why it failed? Let's try to understand. Here it is throwing that the user provided path does not exist. Why does not exist? Here we have seen that if I go to my GitHub repo, here capture2.png is available, and based on that only I have written this particular code, right? But in our GitHub action, it is clearly showing this particular thing is not available, or this is not a proper directory mentioned. Why so? So the reason is in Ubuntu server, wherever this particular GitHub action code will run, there by default these GitHub repo codes will not be available. Why it will not be available by default? Because the reason is it is not like always we need to do something with this code, right? Sometimes we might need to run some other automation which is not exactly related to this particular code base. So that time unnecessarily we no need to pull that old code and clone it in our working directory where in the Ubuntu server this particular GitHub action is running, right? So we need to do that if we need the help of the code in the GitHub action. And for that, what we can do, we can use another action, or within this step we can mention another process which is nothing but checkout. So what it does, it basically fetch the content of the repository and place it in the working directory in the same structure how it is available in the GitHub repository. Okay, so that you can easily utilize this kind of files in your workflow. Okay, in simple words, you can think it is kind of cloning the repository in this particular server. Okay. So here we need to mention another step, that is checkout, action/checkout @v4. Again, this code is developed by some other developer. We are just reusing that. And here you can see the next process within the job is nothing but configuring AWS credentials, which we have done earlier also. And then we are going to execute this AWS S3 command. I'll just copy this particular one and put it here. And here the workflow name is basically this particular one. I'll just update it, and pretty much these things are unchanged. I'll just copy this, and then here I will go to workflow and then main.yaml, and here I will try to update my code, and this time it should not throw the error, right? So let's commit the change and let's hope that it will work properly. So here I can give update checkout main. So here I can save this, and then here let's go to action, and here you can see our commit message came. It should start running. So here it is starting the job. Here it is running the action, first checkout or cloning to the working directory it is doing. Once it is done, it will configure the AWS credential, and once it is done, it is basically going to copy the command. And here you can see all the steps got executed. There is no error. So ideally what should happen in this S3 bucket, here now we should able to see this particular capture2.png. So let's refresh, and here we can see capture2.png. If you want, you can download and confirm both images are same. So here I have downloaded that, and let me go to GitHub also, and let me open capture2.png here also. So here basically this is our channel's image, Krishna Gopal. Okay. And here if I open this capture2.png, here which is downloaded from S3, here also you will see the same image, right? So this is how from GitHub we can move our files to S3. I hope you understood this, Now in the next session, what we will do, we will try to explore integration with Lambda, integration with Glue, and all these things. So now let's discuss the next topic, and that is GitHub integration for Lambda deployment. Okay. For example, you have created a Lambda function for your production system. It is running perfectly fine. Based on event-driven manner, it is doing some computation. Okay. Now the business team is asking for some changes in the business logic. You have done that, and you have pushed the latest changes or committed that latest changes in your GitHub. Okay. Then you want to make sure that from GitHub the Lambda code should be automatically deployed in AWS Lambda service, so that when production system next time the Lambda code will run, it will basically use the latest business logic, right? So to automate this particular process, how we can use GitHub Action, on that I am going to discuss in this video. Okay. So for that, first what we need a Lambda function. So here I have taken a very simple Lambda function which I discussed several times in my previous videos, and what it is doing, it is basically nothing but connecting with Snowflake and creating a table if it is not existing, and then inserting some dummy data in it, right? So here if you see the code, we are importing the Snowflake connector, we are importing the OS module also, because Snowflake username, password, and some PII information we are going to store in Lambda execution environment, and we are going to use OS module to consume that in the runtime. And then we are mentioning database, warehouse, schema, role, etc. We are creating the connector, and we are executing some statement like use warehouse, use database, use role, etc. And then here we are creating the table. Create table if not exist test table. It is having 3 columns basically: call 1, call 2, call 3. Call 1 is integer type, call 2 is string type, and column 3 is timestamp type, where its default value is current timestamp. Okay. And then we are running that query using this particular run query function, and then we are inserting 2 dummy data in the same table, and we are again using run query function to execute that, right? So first what I will do, I will copy this particular code, and here I will go to my AWS management console. From there I'll go to AWS Lambda, and then here I will create the function. Okay. So here I can give the name as Lambda deployment via Git Action. Some name I have given, and the execution environment, maybe I can choose Python 3.10, and here I can create the function. So here our function got created. All I can do is replacing this code with the updated code, and I can deploy this, right? So let's go to our Snowflake system. So here first we are dropping the database if it is existing, just to show you the phrase demo. And then here we are creating this particular database, and here we are executing select star from this particular table. Here you can see the table does not exist as of now. So now we can run our Lambda code to create the table and insert some data in it. But before that, we need to configure the user ID, password, and account details in the Lambda execution environment. So for that, I will go to configuration section. As a general configuration, first what I will do, I will increase the timeout to some higher value like 6 minutes, and I'll save this. And then here I will go to environment variables, and I'll edit this, and I will add all the environment variables. One is user ID, another one is password, and another one is our account details, right? So here, because these are PII data, I cannot show you the value part. Just I will update the value part, and I will click on save. So here I have configured my environmental variable, and now let's test it out whether it is working or not. So I'll go to test, and I'll click on test. Okay. So here you can see it failed. And what is the error message it is throwing? That unable to import module Lambda function, no module name Snowflake. So why the error is coming? It is coming because here if you see in the code, we are importing Snowflake connector as SF, and it is not available by default in our Lambda execution environment. So can we do this particular Lambda dependency installation and Lambda zip file creation also in the GitHub Action only? And the answer is yes. So how we can do that? Basically using this particular architecture. So here we are having our developer, they are pushing the code or committing the code in the GitHub repository, and based on that our GitHub Action will trigger the YAML file, and in the YAML file we will put all the external dependencies, whatever needed, whatever we need to install using pip command, that we will mention here. So here what it will do, GitHub Action, when it will be executing in the execution environment, that time first it will do all the pip installation, and it will put the Lambda code also there, and it will create the zip file, and that zip file it will update in our Lambda function, right? So that way our Lambda function will be having the updated code along with all the external Python dependencies. Cool. So that way our code will not face any issue, and this way we can basically streamline the deployment process also using GitHub Action. So that's what we have written here. If you see, the name is Lambda zip test, and then here job. So job name I can give something like Lambda demo, and then it runs on Ubuntu machine. And this step within the job, we are having multiple steps. As a first step, we are doing a checkout, and then as part of the next step, we are configuring AWS access key and secret key, because here once the zip file get created using AWS CLI, we need to update the Lambda code. So that time from GitHub system, which is basically nothing but an external system, from there we need to interact with AWS. So for that we should have AWS access key, secret key and region configured beforehand. Okay. And then as part of the next step, we are going to create the deployment zip file. Here what we are doing, we are first installing zip so that we can basically zip all the Python dependencies and Lambda code and make a single zip file. And then we are creating a directory where we will do all the pip installation. And then here we are executing pip install command with all the proper configuration, and target directory we are mentioning the deployment zip, basically what we have created here. Okay. And when we create Lambda deployment zip, then along with the Python dependencies, we have to make sure that the Lambda function.py, that code also available in that zip file, right? So Lambda function.py file also we will put in this particular directory. We are basically copying from root directory to this directory. So this is our code, right? What I will do, I will just update this in my root directory. So here I'll go to add files, upload files, and here choose your file. I'll go to desktop, and Lambda function.py I'll upload here. Okay. So here our Lambda function.py is available. So GitHub will consume from the current working directory, and then it will put in the deployment zip directory. That's what this command is doing. Now in this deployment zip, we are having all the external Python dependencies as well as the Lambda code. So we are just doing a zip, right? And once the zip is done, we can basically execute the next step, and that is basically Lambda code update. Okay. And what this particular code is doing, it is basically updating the Lambda function. So in our case, the Lambda function name is this one, right? I'll just copy my Lambda function and function name I will put, and the zip file I'll basically consume from my current working directory. Within that deployment zip is basically that folder where our zip file is available, and the zip file name is lambda zip.zip, right? So that we are putting. And always we have to make sure whenever we are updating our Lambda function using some zip file, we need to make sure that this thing we are putting, that is file b : / before the original file location, right? So this is our Lambda code. All we are doing, we are creating a directory, and then we are installing all the dependencies. We are keeping our Lambda code also there. We are creating the zip file, and all the norms, whatever I have discussed in my previous video while creating Lambda zip, is applicable here also. Like for example, the file name which have the actual Lambda function, that file name is lambda function.py, and within that the main Lambda code should have the name lambda_handler, right? So this thing I have already discussed. That same pattern I am following here also. Okay. So now here what I will do, I'll copy this particular code, and then here I will update my GitHub action or GitHub workflow. Okay. So here I will go to this, and here we are having our main.yaml. I'll just update it. So here I have updated, and I'll commit the change. The changes are committed. And now let's see if I go to our workflow, and if I refresh here, you can see that the GitHub action started. I can go inside this particular one. It is starting the job. Currently here, if you see, we are having our old Lambda code only. If I refresh, so here as of now we are having our old Lambda code, but let's see what happens. So here you can see all the steps got executed. If you want, you can expand individual steps, and you can see all the installation it is doing, zipping it is doing, and all. And now, because now the Lambda code is replaced with zip file, if I refresh, I might not able to see the code. because it might show this. Your Lambda zip file is very big. It cannot be shown something like that. If you see here, the deployment package of your Lambda function is too large to enable inline code editing. Okay. However, you still can invoke the Lambda function. This is a typical message every time it shows whenever we deploy the Lambda code as zip file. Now let's go back to our Snowflake. So here if you see, till now the table is not existing and earlier our Lambda code has thrown error. Now we will run our Lambda code and will observe whether it is throwing error or not. Okay. So here I will go to my Lambda and I will click on test event. So here you can see execution is successful, right? So let's see whether the table got created or not, because ultimately what this Lambda function is doing is nothing but it is creating a table if not exist, and it is inserting some dummy data in it for column 1 and column 2, and the timestamp column it is by default taking current timestamp, right? So here I will run this particular one. See, let's start from this, and here you can easily see that we got our table. So here if I just execute show tables and I'll just run it. Here as of now you can see in the Ramu database within public schema we are having only one table, and that is test table. Okay. Now suppose the business requirement got changed and the table name, let's consider instead of test table I am putting test table 1, 2, 3. Okay. And this is the table name. This is our updated code. What I can do, I can update this particular code, or suppose the developer is pushing that particular code in this particular GitHub. Okay. So add files, upload files. I'll upload my latest Lambda code. Lambda function.py, and here I will commit the changes. Okay. So as a new business requirement, we have updated the Lambda code and we have pushed it. So now what should happen? Automatically using GitHub Action, the code should be deployed in the prod server. Let's see. Our GitHub Action should have triggered. If I go to my action, here you can see that here one action is running. I can expand that particular one. Here now it is in Lambda function update code, and here it is completed now. Okay. So once I execute this particular code, what should happen? A new table should have been created in Snowflake, that is test table 1, 2, 3, right? Currently in our this particular database we are having only one table. All I will do, I'll run the code. Just I'll click on test again, and here it is executing, and execution is completed. And here if I now execute show tables, here you will see that another table got created just now, and that is test table 1, 2, 3. If I just execute, see, let's start from ramu.public.test table 1, 2, 3, we are having our data, right? So I hope this way you understood how from GitHub we can deploy our updated code to Lambda. Just remember this particular diagram flow, that is developer is pushing the code. In the YAML file we need to make sure we are putting all the external Python dependencies, we are doing the pip installation properly, and along with the Lambda function.py we are zipping all them up, and using that zip file we are updating our Lambda code, and that is done using the last step. Okay, that is AWS Lambda update function code. As simple as that. So here we are not doing anything new. Like in our previous video when we discussed Hello World program, that time only we discussed this topic, right? That using run : we can put any bash command to be executed. And here we are doing that activity only. If you see here, using this particular run command, first we are doing all this pip installation and Lambda function copy and zipping and all these things, right? So multiple bash command also, or multiple shell scripts also we can execute using run command. I hope you can easily understand. And then we are taking help of AWS CLI just to update the Lambda function. And as a first step to set up the connectivity between GitHub server and the AWS account, we are setting up the access key, secret key, and region. That's it, right? So I hope the integration or continuous deployment of Lambda function using GitHub Action is clear to you. I'll be putting this particular YAML file in the description box. Just try to play with it and have fun. Then you will understand all these concepts in a much better way. In our next session, we will come up with some other AWS service and GitHub Action integration. Stay tuned. So now let's consider our next integration, and that is Snowflake with GitHub Action. Okay, that is, for example, suppose you have written one particular file where multiple SQL queries are there. That can be table creation code or Snowpipe creation code or any kind of DDL or DML statement, and you want to make sure that as soon as you commit that code or push that code in your GitHub repository, automatically that code should be deployed in your Snowflake account. If you want to automate that particular process, how to do that using GitHub Action, on that I am going to discuss in this particular section of the video. Okay, so for this particular demo, I am going to take help of this quick start Snowflake document. And here basically they have beautifully documented how to do CI/CD using GitHub Action and schema change, which is nothing but a Python module using these two, how to do Snowflake CI/CD. This document has clearly mentioned that, and we are going to follow these steps to implement CI/CD for our Snowflake. Okay, so here you can go through the intro section. Here I am not going through that. I am going to next. And here it just gave little bit idea about GitHub Action, which I already covered. Here it has given introduction about schema change. Ultimately, you can consider like this way. It is a lightweight Python based tool to manage all your Snowflake objects. That's all you can think of schema change as of now. If you want, you can deep dive into schema change concepts using this documentation. I'll be sharing some more documentation link related to schema change in the description box. Obviously, you can explore. But as of now, let us try to understand quickly how to set up the CI/CD using schema change and GitHub Action for our Snowflake. Okay. So I'll click on next. So here what it is saying that first you have to create a SQL file, whatever you want to deploy. Okay, suppose for example this particular query set, if you consider here, first it is creating a schema and then it is creating a table. Okay, like that let me first create one particular script and let's consider these two SQL queries. I'll put these two. Here what we are doing, we are creating a table with the name test table 123 within demo YT CI/CD database and in public schema. And in the second query, we are doing an insert into command in the column 1 and column 2. So column 1 is integer type, column 2 is string type, and column 3 is basically timestamp. Its default value is current timestamp. Okay, so I am not explicitly inserting the timestamp, so it will take the current timestamp value. And two SQL queries, we have to make sure we are separating by semicolon. Okay, now what is the file name we should be giving? Just let's copy this one. Here the versioning is very important. Whenever we are doing CI/CD in this automated fashion, keep an eye on this particular version, because next time when you are doing the CI/CD process, you should increase that version. Okay, that's how schema change works. So here what I can do, I can go to new folder and here I can basically put my script v1.1.1 and initial objects. Here I can give the name as demo.yt.sql. Okay, this is an SQL file, so I will choose all types and I will save it. Okay, so our SQL script is ready. Now let's go to the next one. What it is saying here, it is telling that create action secrets. So GitHub will try to interact with Snowflake using schema change module, right? So obviously we need to provide the account details, username, password and all this. And what GitHub is suggesting, instead of putting directly in the YAML file, you can put in secret section within settings. Okay, so let's do that. So here this is our GitHub repo what we have created. If you want, I can just duplicate this particular one and then I can go to the settings of this particular repository. And then here if you see that there is an option called secrets and variable, I will just click on action. So here I can put repository secrets. So here I will click on new repo secrets and here I can put the secret name and the value part. Okay, it is nothing but a dictionary. So that's what is mentioned in this particular document, that SF account, SF username and all these things we have to mention. Okay, so here I will mention that. Let's go to the next page. So here if you see, we are having our action workflow code, which is our actual YAML code, right? So all I will do, I will copy this particular code and I will put in Notepad and then I'll explain at each line what it is trying to do. So here if you see the name of the workflow, first it is providing Snowflake DevOps demo. So I can give the name as CI/CD demo YT Snowflake. Okay, suppose this is our workflow name, that is fine. And then here it is saying that if push event occurs in the main branch, okay, but not in the root directory or GitHub's main working directory, but rather within the main branch in the migrations folder, there if some push event occurs, then you execute this particular code. Okay, so earlier if you observe this particular Lambda code, whenever we have discussed, here on push we have simply written, that means whenever some push event is occurring anywhere in our repository. But here we are explicitly mentioning in this migration folder, if some change is happening or push is happening, then only execute this script. So what we can do, whatever code I want to deploy in my Snowflake account, that I have to make sure those SQL query files I should be putting in migration folder. Okay. Then here, this particular thing, what it is saying, that allows you to run this workflow manually from the action tab. I don't want to do that. I want to make sure whenever push is happening, that time automatically the code should run. So I can remove this particular section. Then here, jobs. So what it is saying, that deploy Snowflake changes job. So this is nothing but the job name. Runs on Ubuntu latest. So in our Ubuntu machine, basically this particular GitHub action code will run. As a first step, by default, it is doing that checkout, right? And as part of the next step, it is calling some action which is predefined or built-in function. It is basically used to configure certain Python in our execution environment. Like in this case, the Python version, what it will configure in this Ubuntu machine where it will run is nothing but 3.8.x. I don't want to do that because I am fine with the Ubuntu's default version as of now. If you want, you can keep this. I can delete this one as well. Then here, run schema change. This is basically actual thing what is taking care of that deployment section. So here if you see, these are the set of secrets what this particular YAML file is expecting to pre-configured in our GitHub secret storage. Okay. So I'll do that. So first is SF account. So here I will go to my secret and here I will put my SF account. So here this is my account basically. What I will do, I will open the worksheet in a new tab. And then here I will go to admin section and then here I'll go to account section and basically this is my account. Okay, I'll copy this one. I will go back to my secret and I don't need to put this https:// and after AWS this snowflakecomputing.com also I can ignore. Only the unique identifier and then region, then .aws I am keeping. Okay, I'll add this secret. Then as part of the next secret, I need to put the username. Okay, cool. So I'll just add that one also. So I will put my username, which I cannot show you. And then as part of the next value, I need to put Snowflake role, what this schema change will be using to deploy that particular script. So here I will put that. I am using account admin, most powerful role. Okay. Then as part of the next step, we need to mention the warehouse. So I am using the default available warehouse, that is compute_wh. Okay. Then the next step is Snowflake database I need to put. And database name I can maybe put some database. Let me see. So here I am creating a database for this discussion, that is demo YTCICD, and I am creating this database. So here I will choose this particular database only. Cool. I'll add this secret. And as part of the next step, we need to put the password. I'll do that. So here we have configured all the necessary required secrets. And as part of this particular step within this job, it is nothing but extracting those secret values from GitHub and it is configuring in the Ubuntu execution environment where this GitHub action is basically running. Okay. So this is nothing but way of configuring environmental variable. And then as part of the next step, it is basically doing some echo activity and then printing Python version. I don't think these are required. I can just simply delete those. And then here it is basically doing installing schema change. Okay. So what in this step we are doing is, in this Ubuntu latest machine, we need to make sure that schema change module is installed, right? Then only this particular schema change code will able to deploy the code in Snowflake. So for that, as a first step, we are installing schema change. And as part of the next step, we are running this schema change where this is basically default code, how the module generally works, that is schema change. And then here GitHub workspace migration. Okay. So what it is saying, that within my GitHub workspace migration folder, it will monitor and whatever change will happen, that alone it will deploy in our Snowflake system. So here initially GitHub workspace was there as environmental variable or somewhere they have configured, but I deleted that. So I can remove from here also, and I want to make sure just migration folder is available within our root directory. So I just putting like this way. Okay. And then here SF account, username, roles, warehouse, database, and then all these things it is taking. It will just create a table also where we can monitor that what are the codes it has deployed. So that is another good thing. And we can basically put this particular script in our GitHub action. Okay. So I will copy this particular code and here I can go to GitHub workflows. So I'll open this. So earlier we were already having one particular YAML file which is monitoring all the push event, and whenever something is happening it is just printing hello world. So you can put multiple GitHub action code. It is not like only one you have to put. So here what I can do, I can add a file, create a new file, and here this is our Snowflake schema change deployment code, and here I can write sf cicd demo yt07.yml. okay, because these are YAML files. So I can commit the changes. Okay, cool. As soon as I will commit, obviously it will try to run main.yaml, but this command will not run because this command will only be triggered when in migration folder something is happening and we have not done yet. Okay, so this code will not run, but because we changed and pushed the code of our Snowflake CI/CD deployment file, this particular YAML file will be executed once. So if you see our actions, here you will see that due to this particular file creation, my first GitHub action got executed. That is basically nothing but this one. Okay, so till now it is fine only as expected. Now we need to create a migration folder, and there we can put this particular file code to see how it is working. Okay, so here what I will do, initially I'll just create migration folder manually. So here I will go to create new file, and here I will put the folder name migration and then slash, and here I will put my code. Okay, so basically it is creating the migration folder. Within that I can put my file name. So here I will just copy the file name. Somewhere rename should be there. Yeah, I'll copy this, and here I will paste this, and the file name is .sql. Okay, but before committing the changes, I want to show you our Snowflake status. As of now, if I refresh this, here you will see that demo ytcicd database is there. Within that there is a public schema, but there is no object currently. Okay, just we created that database, that's it. If I just do show tables, use database, and then if I execute show tables, here you can see currently nothing is there. Now we are ready to see deployment in action. I will just commit the changes, and because this particular git push is happening within migration folder, so ideally schema change should detect this and deploy it. So I'll just commit these changes, and let's see, let's go to our workflow. Two workflows should be started. One is basically my first GitHub action, and another one should be our schema change. So here only one got started. Let's see why it is happening. So let me just double confirm. So here I will go to this particular file, okay, sorry. So the path name, if you see here, it is given migrations, not migration, and by mistake I have given this particular name as migration, right? So here what I will do, I will just create a migrations folder. So create new file, and here I'll just copy the name from here better for safer side. So the folder name is migrations, and there I'll just put the file. And the file name I'll copy and then paste that here. Okay, I'll commit the changes. So now let's see our action. I'll go to action section, and now see two YAML files or two GitHub actions started. One is CI/CD demo YT Snowflake. So this is our main point of interest. Here you can see the job is started, setup is done, checkout repository is done. It is running the schema change. Let's hope we'll not get any error. So here you can see it is printing running schema change, and here the job is complete. That means all things are done properly. Now let's see whether these two queries outcome are reflected in Snowflake or not. Here what we are trying to do, we are basically trying to create a table and then inserting some data in it. So earlier we seen no object. Now I will refresh this, and here you can see there is a tables created, and within this table there is a test table 1, 2, 3. So let's see the content of this. So I will just place name, and then here select star from. So I'll just execute, and here you can see the data got inserted successfully. Not only that, here another point to be noted is there is one more schema got created, and that is schema change. If I expand that, within that there is tables, and here is change history. Okay, so here I can do select star from this change history. Let's see what it is having. So I'll just run this, and then here you can see it has basically captured the metadata information. Like here it can be used for auditing or logging purpose. Like this is the version name, this is the script, and this is deployment time, how much it took, installed by, and status. All this information it is basically printing here. Okay, so this particular table can be used for audit or logging purpose, right? So now let's see another thing. What I can do, I can copy this particular script, paste in a new script, and here maybe I can give the name test table 1 2 3 4, and here I can give 4, some other data randomly I am putting, maybe 4 5 6 7 7, test 2 string 2, test 2 string 1, like that. Okay, and then here I will try to save this. So all types. So here this is how you have to configure the name. Just have an attention on that name properly. So here v1.1, then here .1. Okay, so I need to change the version to a higher value. So v1.1.2 I will do. Okay, or here I can do the change like second time. Okay, and then here this is an SQL file. I'll just save this. Okay, right, cool. And what we'll do, we will basically upload this in our migration folder. So I'll add files, upload files, choose new folder, and I'll choose my file, open it, and commit the changes. So here changes are committed automatically. Immediately here our 2 GitHub Actions started. We are interested in CI/CD demo YT. Point to be noted, earlier file will not be picked up again. Okay, it will just pick up only that particular file where there is some changes. Otherwise it will not pick up that. That is another interesting thing. So you can see in the logs that only the changed file is picked up. Here if you see that applying changes script v1.1.2, but although in our migrations folder both these scripts are available, see, but here it has picked up only this particular script. Okay, and while using schema change and GitHub Action, not only this kind of simple code you can execute, but using this basically you can execute all kind of Snowflake queries. Like here one sample example, we are creating a table, and then here we are creating the file format, we are creating some external stage, and we are executing a copy into command in it. Okay, so here first let me show you this particular table is not existing in our Snowflake account. So here if I execute select start from this particular one, here you can see it does not exist. Okay, right? So here I will commit this particular code in my GitHub, and I can expect all these commands should be executed automatically. So here I will go to my migrations folder and I will upload some file. Okay, so file name I will save as some higher version like v1.1. maybe 11 I can put, and then here copy command and .sql I can put, and this is basically all types, and I can copy this one and save this one. Okay, so this is one SQL query, and here I can go to add files, upload, choose file, and this is our file. I'll just commit these changes. So one push event happened in our migrations folder, so we can expect our workflow should be started. So here you can see this particular CI/CD process is started, and here it is in running state. We have seen that this table is not existing, and we can hope that once the deployment successful, we can see that table. So here you can see all things are checked. That means the deployment is successful. Let's go to our Snowflake, and if I execute now, here we should be able to see the data in it. Okay, so this is one sample data what we were basically having in our this particular S3 stage, and from that stage we have created the table using this GitHub CI/CD, and then it has executed the copy into command to ingest the data from external stage to the Snowflake table, right? So I hope you understood the fundamental concept of schema change, GitHub Action, and Snowflake CI/CD. All you need to make sure that always next time whenever you are deploying one SQL file, increase the version properly and just be very careful with the secret keys and all. And apart from that, I will be providing this particular modified version of our YAML code in the description box so that you can parallelly practice this, or you can basically use the default code what is available in this particular documentation as well. Just follow this particular one. You can make this project properly. If you have any doubt at any point of time, you can obviously ask in the comment section. This is all about Snowflake CI/CD using GitHub Action and schema change. Thank you. So now we are going to explore our next integration, and that is CI/CD with GitHub Action and Amazon EC2 machine. Okay. That is, for example, suppose we are having one EC2 Ubuntu machine, which is basically nothing but our production server, and we are having our production GitHub repo also. Whenever in that particular repository we are committing and pushing some code, that time if we want to automatically deploy that code from GitHub to our EC2 machine, how to do that using GitHub Action? On that we are going to explore in this particular section of the video. Okay. So as a first step, what I will do, I will quickly launch one Amazon EC2 machine as part of this. So here you can see currently I am in my AWS management console in EC2 dashboard, and I will click on launch instance, and here I can give the name as EC2 Git Action Demo YT11. Okay, and in here Ubuntu machine I can choose. Let's consider our production system is Ubuntu type, and here I will choose basically this particular free tier one, and instance type I am keeping T2 micro because this is just a POC. Key pair, I am having one existing key pair, I am choosing that, and here if needed you can enable these two as of now as part of POC purpose, and keeping all other properties unchanged, we can launch this instance. Okay, so here you can see the instance is getting launched. So here I can click on this particular one to go to my instance, which is currently in pending state. I can click on that. This is our public IP. I'll just update this security group so that it will be accessible from anywhere. Edit the inbound rule, add rule. As of now, I will allow all traffic from anywhere IPv4 location, and I'll save this rule. Okay. So here I can go to instances, and here still it is in pending state. We need to wait for some time, and here you can see currently it is in running state. So I will just copy the public IP, and here I am going to use putty to do SSH into the server. Okay. Here I am going to choose my key pair file, and I'll click on open. Right here you can click on yes, and here login as. So because this is an Ubuntu machine, so by default the login ID is Ubuntu, UBUNTU. Okay, I just click, and here it is authenticating, and here authentication is done. To avoid timeout, I will just change the setting to 10 seconds. Okay, and I will click on apply. Now what we are going to do using GitHub Action basically is that we will do SSH into this particular server using the PPK or PEM file and the EC2 server IP, and then in a particular directory we need to execute git pull command. Right now, before executing git pull command and bring all the latest changes in the server from GitHub, we need to set up GitHub in this server. Right, so as the next step we are going to do that. And to set up the GitHub configuration in EC2, we need to execute these codes which I already discussed in my previous video. First, we are going to update if anything is not updated, and I'll click on Y. And then as part of the next step, we are going to install Git, and we can execute Git version to check whether Git is installed or not. Okay. So here the update code, let it get executed. So here it is done. And now here if I execute Git version, here it is showing Git version 2.25.1. So already Git is installed here. So I no need to execute sudo apt install Git. Now I can directly go with the configuration. So here I need to provide the username. So I'll put that, maybe some random username I am putting. Now here user email ID. So I'll put my email ID, and here also for this code also you need to put that. I'll just do that, and I'll execute all these three codes together. So here it will generate the key pair file. I'll just click on enter. Okay, and it is generated. Right now here I need to execute this command. Already I discussed multiple times these things, so I'm just going quickly. You can check the description link for detailed explanation. Now whatever the key file got generated, that is available in this particular path. So first I will add this, and once it is added, I can basically execute the cat command to view the public key. Okay, and this is our public key. I'll just copy this public key and I need to configure in my GitHub. Okay, so here we are in our GitHub account. I can go to settings, I'll open in new tab, and then here SSH and GPG keys are there. I will click on that, and here I will maybe delete the existing one, and I can click on new SSH key, demo EC2 GitHub Action test. Okay, so here I can put my GitHub integration public key, and here I will add the SSH key. Okay, right? So up to this step it is done. Now here what we'll do, we will basically execute git clone command to clone the repository in a particular EC2 directory. Okay, so for that, first I am going to create a directory, mkdir GitHub codebase, and here if I do ls, here you will see GitHub codebase is created, and now we can clone our repository. Okay, so here I can go to code, and here I can copy the SSH URL, and here I can paste it. Okay, so what this is going to do, git clone this particular repository, it will clone in the GitHub codebase. Okay, so GitHub codebase absolute path I am putting. If you see here pwd, if I do, it is nothing but home Ubuntu. So basically for this particular folder, the complete path is home Ubuntu, then GitHub codebase, right? That's what I have written here. Okay, so it will make sure the git clone is happening in that directory, and here I will write yes, and here it is done. So if I do ls, here this is my directory, I'll just go inside this particular directory, and then here I can execute ls lrt maybe, and here you can see that 2 folders and lambda.py, capture2.py, these total 4 entities came. And here if you see in our GitHub, migrations, capture2.png, lambda function.py, these are the main things. Don't consider the workflow because this is just used for CI/CD. So by default, GitHub will always ignore this. Okay. Now we need to know how to integrate GitHub Action with this EC2. Okay. So for this, instead of writing the code from Google, I am going to show you the power of ChatGPT. So here I am having my ChatGPT open, and here I can simply ask, write a GitHub Action code to auto deploy the code from GitHub repo to EC2 server whenever some git push occurred in our repo. So I'll just ask ChatGPT to write this code. Let's see what it is writing. So here you can see it has given a code. I'll just copy this particular code. What other things the ChatGPT is providing, you can obviously check in your case. So here let's go through that quickly. Here the workflow name is deploy to EC2. On push event, branch is main branch. That is fine. Okay, because we want to make sure in the main branch only if any code is pushed, that is basically our production branch, then only this auto deployment should happen. Okay. Then here the job will run in Ubuntu latest. That is fine. Then first it is doing checkout. That is also okay. Now from GitHub Action, that is basically running in one Ubuntu machine, right? From there we need to enter in the EC2 server. So for that we need to execute some SSH command in the backend, right? So for that SSH command execution, we are having some pre-built step, and that is basically this one. Okay, web factory /SSH agent. All we need to do is provide the SSH private key here, and where we are configuring within secret, there is a key we can keep SSH private key, and within that in the value part we can put the SSH key which is required to perform SSH operation from one Ubuntu machine to our EC2 server. Okay, so I will just do that SSH private key, but first we need to generate the private key. So whenever we launch EC2 machine here, that time we needed one key, right? So we download as PPK file, but here to do SSH we need the PEM file. So from the PPK file we will convert the PEM file using puttigen. So here I will search puttigen, and here I will load my PPK file, and I will convert this to PEM. Okay, so conversion, export OpenSSH key, yes, and here I can give the name as PEM file demo yt EC2. Okay, .em. So and I can save this one. Now we have the SSH private key. So all I will do, I will go to my GitHub repository. I will go to the settings section of this, and then here we are having the code security and analysis and deploy key and secrets and variable. I'll just click secrets and click on action, and then here earlier we configured all these secret keys, so I'll just put a new secret, and here I will add the secret. Okay, so for adding the secret, I will open the PEM file, whatever just now we created. So here this is the file. I'll copy this one, and then here I'll paste that. Okay, that is done. And here secret key name. So in this particular code, our secret key name should be SSH private key, right? Then only it will be able to consume that from this secret store. I'll add the secret. Okay, so the secret is added. Cool. And then as part of the next step, what it is doing, it is deploying to EC2. For that, SSH EC2 user. So by default, it is thinking that the user name for our EC2 machine is EC2 user. That is basically default user ID for Linux machine. But here we are using Ubuntu. So I will just type Ubuntu. Okay. And then here your EC2 IP address. So I'll put my EC2 IP address, which is basically nothing but this particular one, public IP. And I'll paste that. And then here what we are doing, we are basically entering in some directory and we are executing git pull command, and then if needed we can execute certain shell script and all. So this part is not needed for our this particular demo discussion. Here cd to my path. So in this case I'll update with my path, that is basically nothing but here where our GitHub is configured. I'll just do that, and then here git pull origin main, that we can keep as is. Okay, so with this, using simple ChatGPT code, our GitHub workflow code is ready, which can push the latest code to our EC2 machine whenever some push event occurs in our main branch. Okay, so it's time to test. What I will do, I will go to my GitHub workflow. Okay, and here earlier we were using this particular YAML file for Snowflake related testing. I'll just update that one only. I'll just remove the code and paste this here. Okay, no other changes there. SSH private key we have configured, the IP we have updated, and we can hope that it will be able to execute the git pull successfully. So here what I will do, I will commit the changes. Commit. Okay, once it is committed, I can go to actions and let's see whether it is running or not. And here you can see deploy to EC2, this is started. This is basically our first YAML file, which was just doing a echo command. So ignore that. Let's enter inside that and let's see whether it is throwing any error or not. Okay, so here it has thrown some error. What it is there? Host key verification failed. Okay, so host key verification failed means our PEM file might have some issue for which it is not able to execute the SSH command. So let's see. The PEM file demo YT issue. So this one I have updated it, right? Let's just double confirm. So here in this repository, you can go to the settings section. Action. SSH private key. The private key is updated. Let's ask ChatGPT this particular error how to resolve. The host key verification failed error typically occur when SSH connection from GitHub Action to our EC2 instance cannot verify authenticity of the host. This happens because EC2 instance host key is not yet known to GitHub Action runner. To resolve this issue, you can add a step to your workflow that will ensure host key is added to the known host file. So here what it is doing, this code is same. I think this particular part we are adding extra. So let me just put this particular one also. I'll copy the whole code and paste it here. This is the section actually. So here these properties are unchanged. Your EC2 IP address is basically this particular one. I'll just put that and that is fine. And here this comment I'll just update with my code. And pretty much no need to do more changes. I'll just copy this one and let's see I change it whether it will work or not. Here I'll comment the changes. So GitHub Action should be started. Deploy to EC2. Let's go inside this, and here you can see all the codes got successfully executed. Okay, so that means our GitHub Action is successfully working. So now it's time to test it out whether it is properly working or not. Here earlier these files we were having, and now suppose what I am doing, I'm going to my repository, and in here I will add some files. So here I'm going to choose some file for this demo. First I will choose one, open, and here one GIF file I am uploading. So suppose this is our latest changes in GitHub. We are committing these changes, and here earlier if you have seen that when I executed lsLRT, that particular file was not available, this timeseries.gif. Now automatically in the backend GitHub Action should run, and timeseries.gif should come anytime in our production server. So let's keep on executing lsLRT, and here if you see in our actions, by default this deployment code is triggered automatically because we have done some push event in our this repo, and it is successful. So if I just execute lsLRT, here you can see timeseries.gif came. And if you see the timestamp, here all are 455 on December 11, but this timeseries.gif is having December 11 508 because it came later, right? Now another last file I can upload just to show you whether it is working perfectly fine or not. I'll choose the file, and then here maybe I will choose one resume file, and here I will upload, commit the changes, and here it is committed. And now here this particular science resume.pdf is latest one. By default here you can see our this particular code is started, and let's execute lsLRT. Till now it has not came yet. Let's refresh our workflow, and here you can see it is deployed. So now here if I execute lsLRT, here this particular file arrived, right? So here you can understand that from GitHub automatically the code is getting deployed to our EC2 machine, and the complete code is written by ChatGPT. Okay, even initially we got some issues or errors, ChatGPT helped us in resolving that. So this way you can utilize the cutting edge AI tools to faster your development process, right? So I hope you understood this particular one. Try to play with this particular lab section. You will understand all the concepts in much better way. So now we are going to explore the last integration with respect to GitHub Action and AWS Services, and that is CI/CD for AWS Glue job using GitHub Action. Okay, that is, for example, we are having a Spark code which is running in production system using AWS Glue service, and after a few months of production deployment, the business team requested some changes in that existing code. You have done that, you have committed and pushed your code in GitHub repository, and you want to make sure from the GitHub repository automatically the Glue job should be deployed in your production AWS account. So how to do that using GitHub Action in automated manner? On that we are going to explore the technique in this particular section of the video. Okay, so first for that let me create a Glue job, and here we are having a very simple Glue job. I am not implementing any complex transformation, because once we understand the CI/CD process with this kind of simple job, the same can be implemented for any level of complexities. Okay, so here what we are doing, we are importing all the necessary modules, we are creating the Spark session, and then here what we are doing, we are reading the data from one particular S3 location which is available in CSV file format, and then we are writing the data in another S3 location as Parquet file format. That's it. Okay, so here what I will do, I will copy this particular piece of code. I will go to my AWS management console. From there I will go to AWS Glue, and here I will go to ETL jobs, and I will create a job quickly. Okay, so create job from blank graph. I'll go to script, edit script, confirm, and here I will paste my updated code. Okay, in the job detail section I can give the name CSV2 Parquet. Okay, and then IAM role I can choose. Okay, right? And then here language, let it be request number of workers, no need to change. Number of retries I am changing to 2, and then here advanced properties, maybe concurrency instead of 1 I can change to 3. So keeping all other properties almost default, I just change 2 things. One is max concurrency, another one is number of retries. Okay. Now whenever we create AWS Glue job, in the backend the script basically gets stored in one S3 path. So here you can see that S3 path, that is script path. Okay. If you want, you can click on view. It will open the S3 location in a new tab, and here as of now there is no script. As soon as I will save this particular job, the script file will be created in that S3 location. Okay. So let's go here, and if I refresh, here you can see this CSV to parquet.py file came. Right. So as part of GitHub Action, what we can plan that all we need to do, we need to basically execute AWS S3 CP command from GitHub Action, and there we will mention the Python file which we want to replace in this particular Python file. And whenever we will update in this S3 location, then and there the code will be updated in this Glue script also, because it is nothing but the backend code we are updating, right? So that way it will be reflecting here also, as simple as that. Okay, right? So here what I will do first, I will show you the normal run. So here what I can do, I can open maybe S3 in a new tab, and I can go to bucket section, and here I can search for this particular bucket. Here basically this will be treated as destination bucket for our Glue job, where it will be writing the Parquet data. Currently it is completely empty. And let's see our source data also. We are having credence set. This is one particular bucket, and here we are having a CSV file, setusa.csv, right? So we are going to use this particular CSV file for our Glue job. So let me just update this particular path, and I will save this. So here we are reading setusa.csv and we are writing and publish here. Cool. So what I will do, I will run this job. I'll go to ETL and I will refresh. Here we are having our job, and here I can click on run job. And here you can see successfully started. If you want to observe the progress, here you are getting an option job run monitoring. Open that in a new tab, and here you will see that CSV to Parquet is in running state. So let's wait for a couple of minutes till it gets complete. And here you can see now the job run status is succeeded. That means we can expect that it has read the data from this particular source location, and it has written the Parquet file in the publish folder within this particular bucket, right? Because that's how we have configured. Within this particular bucket, the folder should be published, right? So here I can go inside that, and here you can see that we are having our Parquet file. Okay. If you want, you can query this particular Parquet file also, not a problem. Query with S3 select you can do. Apache Parquet, I want to get the output format as JSON and limit 5. If I run it simply, here you will be able to see our data. So as you know that in our iris dataset, we are having sepal length, petal width and class name. So that's what we are getting here. Okay. We are not applying any transformation. All we are doing is converting the data from CSV to Parquet. Cool. Now what we can do, suppose we need to make the changes in the code, and the changes, instead of directly writing the output in publish folder, I have to first create a folder called GitHub Action, then / then publish. Okay. So within this particular bucket, we should be having a folder called GitHub Action. Within that, we should be having the publish folder. This is the code change. Okay. Now we need to deploy this automatically. So for that, what I will do first, I will take my secret credentials from AWS. So here we are having access key. I'll create the access key. I understand, create key. And then here I will first go to my YAML file and I will update, and then I'll explain what I am doing here. Okay. First, we have configured that it should run on Ubuntu latest. And then here we are doing checkout. Then here we are configuring AWS environment, because ultimately we need to execute one AWS S3 CP command from GitHub Compute Engine, where this particular GitHub Action is running, right? So for that, AWS access key, secret key and all needed. Now here where I need to update, I need to copy this particular CSV to Parquet, this updated file, to this particular location where our Glue script is as of now available, and that is this one. I'll just go to this particular Python file and I'll copy this particular S3 URL and I'll paste that here. Okay. I no need to put this particular end part. I can delete that. So here, this is our destination. Now we need to configure our source. So our source is basically this particular one, right? So I'll just save this. CSV to Parquet file is saved, and now we are ready to configure in our GitHub account. Okay, so I'll go to my GitHub. This is our repository, and I'll go to workflow, and here this main.yaml is nothing but printing hello world. I'll just edit the second YAML. You can create as many YAML as needed, and here I can paste this particular piece of code. Okay, all I need to make sure is AWS EC2 from where it will copy the file. Okay, so this particular CSV to Parquet, this file I'll be uploading in the root level of our repository. So I can give dot, then slash, and then here I can give the file name, and in our case the file name is CSV to Parquet. I'll just copy the file name from here, CSV to Parquet.py. Okay, so what it is doing, from the root level of our repository, it will copy the CSV to Parquet.py to this particular script folder, and as soon as the CSV to Parquet will be updated here, automatically our Glue job will be updated here, right? That's what we can expect as part of this particular GitHub Action automation process. So what I will do, I will commit the changes, and I'll commit here. So initially what might happen, that the job might fail, because here in our this particular directory CSV to Parquet file is not available. So let's see our action. Our action should be getting triggered, because here if you see this particular YAML code, here on push event we are basically triggering this particular action. So when we committed the Glue YAML file, then basically it is nothing but a push event, and here it got triggered automatically, and here it failed, and the reason for failure is our CSV to Parquet file is not available, right? So that's what it is writing here, the user provided path does not exist. So now what I will do, I will add the file and we'll see whether changes get reflected or not, or in an automated manner. So here till now you can see the Parquet file code is having that older path only, and now we will upload our this particular code, right? So here what I will do, I will go to my GitHub and I'll add files, upload file, choose file, CSV to Parquet I will choose, and I will commit the changes. Okay, as soon as I have committed these changes, here automatically action should be started. Here Glue deployment, this is our focus. So I will go to that. Here it is executing AWS EC2 command. The job is started. First it is doing checkout, and then here it is uploading the Glue code. It is configuring the credentials, and the job is done, right? So that means we can expect that the Glue job is updated automatically. Let's see. Till now it is showing that older path only, but we have configured the new path with GitHub Action, then slash publish, right? So let's refresh this job. So if we refresh, here you can see automatically now the Parquet file location got changed. That means when we have pushed our modified PySpark code in GitHub system, automatically using GitHub Action, it got deployed in our AWS Glue system. Okay, and actually in the backend, what happened? That this particular CSV to Parquet got overwritten. That's all happened, right? If I go to script location, here you can see that last modified is 10 AM 10 minutes 39 seconds. Currently it is 10:11 AM. That means just now this particular Python file got updated using our GitHub Action. So I hope you understood how to easily do CI/CD for PySpark code which is running in AWS Glue system. All we need to do is update our script in the S3 location, and it will be getting reflected in our Glue system also. And here one more point to be noted, if you go to ETL jobs, and here this is our job, right? If I go to the job, if I go to the job details, the other properties are remaining unchanged. So here if you see that number of retries initially we configured 2, till now after this update or deployment also it is 2. And another change we made is basically nothing but the concurrency limit we increased to 3, still it is 3. That means when you are changing the code, other properties are not getting changed, only the script alone is getting updated, right? So I hope you understood this particular process. With this, I hope you got a sufficient idea of integrating various AWS services with GitHub Action and automate our CI/CD process. This is all for this video. If you find this particular video interesting and helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.